Okay, this part you don't have to take notes on because you've technically already done it in Unit 1. When you were 2 years old, what were the numbers you started talking about? Remember we did this before. Your finger numbers, and those are not the integers yet. They were the natural numbers. This was natural for you to start learning about your fingers, which are your counting numbers. 1, 2, 3, la-di-da-di-da. Then, you all of a sudden found out the existence of one more number. What number was that?
Whole number.
A whole number for a 0. There's the W. Whole number is all of the natural numbers, but one more has the whole. And then, I don't know, maybe 2nd, 3rd grade, you start learning about integers. What do the integers have? The negatives. You remember the letter for integers? The Z. Z is our integers. They're negatives. Goes on to infinity in both directions. It's on your right hand, I thought. Okay, after the integers, you were then introduced, once you started dividing, you were starting to be introduced to what? Fractions. What type of numbers have fractions? Decimals. Ooh, there's the word. Oh, it's not that one, the other one. Rational. We use a Q for that. So, Q. Rationals. And rationals are all of, there's 3 types. We have repeating decimals. We have terminating decimals. And anything that can be made into a fraction, which are all the repeating decimals and terminating decimals can be made into fractions. Can the number 2 be made into a fraction? Yeah, just put a 1 underneath all of those, and those are all fractions. Then there is a family outside of the rationals called the irrationals. That's where we use the I. Those are things like pi and square root of 2. Irrational is all of the nons of those. Non-repeating, non-terminating, non-fractions. Well, this was all in the family of real numbers. Well, today, gonna blow your mind. You thought that was all that existed. Guess what? You've been in a locker all your life. So when you're in like elementary school, just little, and you only knew about positive numbers, at first you were those creatures in the locker from the Men in Black movie, right? You thought that was the only world. Then your mind was expanded to Will Smith's version. Will Smith's version was, you have, his name is Jay. All hail Jay. Then you have understanding, a larger understanding of decimals and fractions and irrationals, rationals, all these real numbers. Well, today, what happened when Kay took Jay to that door that said, emergency, don't use this ever, and he kicked it open. He said, man, you've been living in a locker your whole life, or something like that. And he kicked it open, and what did he realize? He wasn't himself in the locker. So all your life, you have been within a locker. And today, we just kicked the door open. Guess what? There's real numbers. And if it's not real, it's imaginary numbers today. Yay! Okay, time for notes. Pull out a piece of paper. And these imaginary numbers come in the form of what we call a complex number. So this is H4. It's in your volume 2 section. There's this section in the back of your volume 2 that's dark blue on the edge. Those are all the honors topics. So we'll be going back and forth from there all year. Complex numbers. Is that a dog? weird. When I taught Kearns, we had the police bring dogs in because they did their practice training. Like, oh, they're probably doing the drug training. Like, they go sniff out your lockers and find who's hiding illegal stuff. They did that in Kearns every year. And they'd always find extra stuff that they didn't plant. Okay. Guys. So, complex numbers is again in that dark blue section of volume 2. Our essential question for today is, nope, what is a conjugate and how is it helpful when adding, subtracting, multiplying, and dividing two complex numbers? I'm going to tell you what a complex number is. Do you know when you get an imaginary number? Do you know how we get imaginary numbers? How? We just imagine it? No, it actually comes from the square roots. Square root of 9 is plus and minus 3, correct? Because a positive 3 times a positive 3 will equal 9. Also, a negative 3 times itself, negative 3 equals 9. What if I did this? What is the square root of negative 9? Can you give me a number times itself that is negative 9? 3 times 3 is positive 9, though. Negative 3 times negative 3 is positive 9. Has to be a number times itself. That's how square roots work. Well, this is actually plus and minus 3i, because there is not a number times itself that would be a negative, because positive times positive will always be a positive, and negative times a negative will always be a negative. So we get imaginary numbers from negative square roots. There's a couple of things you need to know about I. The square root of a negative 1 is the letter I. Well, if we squared I, what's squaring a negative 1 going to give you? Squaring the square root of a negative 1. If I squared the square root of negative 1, it's just negative 1. These are things you need to put into memory. I squared is actually a number, negative 1. And the square root of a negative will pop out an I, because the square root of negative 1 is I. So, a complex number has two parts. A complex number is in the form a plus bi. It has a real piece plus an imaginary piece. If I say plus or minus 3i, that technically is a complex number. Its real piece is 0, plus or minus 3i. Is 0 a real number? Yes. Okay, and 3i is the imaginary part, so this would be how you would write the complex number of plus or minus 3i. This is also standard form. This is the order you should write. Like we have standard form for polynomials is always descending in power. You should always be writing those in standard form. With complex numbers, your standard form is the real part plus the imaginary part. Goes real first, imaginary second. Addition and subtraction of this is really, really easy. So let's add and subtract. It will just feel like all you're doing is combining like terms. Okay? Example 1. 7 minus 3i. Now I'm going to put this in parentheses because all of this guy is a number. It's called a complex number. It has a real part and an imaginary part. Plus 4 plus 5i. Okay? We're going to go through and label R for real. Where's the real parts? 7 and 4. So these guys would be the imaginary parts, right? So if you didn't know about this existence of I, you would have just combined like terms anyway, right? That's pretty much what we do here. Like terms are the real pieces together. 7 plus 4 is 11, and we want to put the real part first, so that's standard form. And then the imaginary parts, negative 3i, make sure you notice the sign, plus 5i is a positive 2i. So if we were adding two complex numbers, we'd get this complex number, 11 plus 2i, which has a real part plus an imaginary part. For addition and subtraction, it's stuff you already know anyway. Example 2, let's try subtraction 1. 2 minus I, subtract the complex number 8 plus 3i. You can even graph these complex numbers, but the way you've always been taught to graph is called the real coordinate plane. There's an imaginary coordinate plane too. What? Mind blown. Mind blown. Okay. Now, I think I'm going to let you try this, guy. Go ahead and try subtracting. Remember, subtraction's a little trickier. Is that subtraction only subtracting the 8, or is it subtracting both? Both. So try it. I'll give you about 20 seconds to try it. Okay, so if you're subtracting both, I would have changed this to negative 8 minus 3i. Sophie, what did you get for your complex solution? Negative 6 minus what? Okay, thumbs up, thumbs down. You agree, don't agree, or middle, I guess, if you have half the same. I see a lot of thumbs up. That's good. I agree. Because 2 minus 8 is negative 6. And as your real part has to come first, imaginary part second. Adding and subtracting, easy. Are you okay with adding and subtracting? Yep. Okay, now we're going to multiply and divide. Let's start with multiplication first. Example 3. 2 plus 3i. We put it in parentheses so we see the whole complex number together, times, and this will seem very similar as well, 5 minus I. So the real piece is 2, the imaginary piece is 3i, real piece is 5, the imaginary piece is negative I. How would you normally have gone about multiplying these? Okay, we do the same thing. That's so nice. 2 times 5. 10. 2 times, negative. Make sure you catch the negative. Negative I would be negative 2i. Okay, Jessica, can you help me distribute the 3i? What would we get if we distribute the 3i? I'm sorry? So positive 15i and then? I can't hear you. I don't think it's negative I. 3i times negative I would be negative 3i squared. Okay, your like terms. You have a question? 3i times negative I, negative 3i squared. Any like terms? Okay, so we have 10 plus 13i minus 3i squared. Well, this doesn't look like standard form, actually, because the standard form only has two parts, a real part and one imaginary part. One of these we can't leave as our answer. If you look at the very, very top of your notes, one of these I told you a value for. Negative 1 for equals what? I squared is a number, so this guy is actually real. What? Oh, snap. 10 plus 13i, you got to look out for that. I squared is actually the number negative 1. Mind blown. I quit. I know, it's rough for your brain. This is negative 3 times I squared. At the very beginning, if we go back up to the top, we said the square root of a negative 1 was I. You remember that? If I square I get I squared. If I square the square root of negative 1, the square cancels out the square root, so I find that I squared is actually the numerical value negative 1. I know, I'm telling you, you've been a walker all your life. New world. Because negative 1 is a real number. I love this lesson because everyone always freaks out. So, we have more like terms, guys. Come on. I know it stretches your brain a lot. It'll be okay. Promise you. Nothing in the steps we've done has been new until I squared being a negative 1. So if I replace it, I get 10 plus 13i. If I multiply those, I have positive 3. So I have actually two real pieces. So I combine them, and I always make sure I do it with the real part first, plus the imaginary part. Yes, Connor. Squaring the square root of negative 1 is I squared. I'm sorry, I'm answering his question right now. Remember, we cannot take the square root of a negative in the real numbers. No number exists times itself would ever give us a negative. A positive times itself is also a positive, which would have to be a positive. A negative times itself is a negative. A negative times negative has to be a positive. There's no way to times a number by itself and get a negative. That's where we branch into the imaginary numbers. I know, right? It's rough. There's one more. Division. Here's where you're going to learn that word that was in the essential question, which even though I said explain it for... Okay, I'll wait till you're done talking. Explain the conjugate and how it applies to addition, subtraction, multiplication, division. Actually, we really only use it mostly in division. So, Wadji, you have a question? Yep, because we have the real piece plus the imaginary piece. That's standard form. Okay, division. Let me get one here. Okay, 5 plus I divided by 2 minus 3i. Well, there are a few things that we don't like as mathematicians in our denominators, or in any of our answers. We never like negative exponents, so when we did exponents, we always change them to positive. We also don't like to have square roots in your denominators. We call that rationalizing a denominator to fix that problem. And we don't like to have i's in the denominator. So right now we have an I in the denominator. The conjugate will be the exact same binomial with one difference. We're going to change the operation. So we're trying, our goal in division is, see how there's an I in the denominator? We don't want it in the denominator. So we're going to multiply by a fancy form of 1 on top and on bottom. The fancy form of 1 is called the conjugate. I'm going to do the exact same binomial, except for the conjugate has the opposite, the inverse operation. If this says minus, what's inverse of that? Plus. Plus. Okay, so we have binomials. I'm going to put all my binomials, all my complex numbers in parentheses. We can do the numerator now. 5 times both of those guys. Harlan, what would you get when you distribute the 5 in? Plus 15i. Okay. Then we have an I. We're just timesing binomials. You guys have known how to do that for a few years now. Aaron, what do we get when we multiply the I in? There's that friendly 3i squared that we can't leave as a 3i squared. Over, now in our denominator, actually let me do this color. In my denominator, Jade, can you distribute the 2 in for me? I'm sorry, I can't hear you. No, they're all positives. 4 plus 6i, and then watch what happens. When I multiply these, I get negative 6i. Boom, boom. Using the conjugate, we'll cancel out the I. And negative 3i times positive 3i, we have negative 3i squared. So, if I find my like terms, I have, these guys are like terms, same steps as multiplication. I see 15 and 2, which is 17i. I might as well change this right now. I squared is what number? Did I make a mistake? Oh, okay. Thank you. 3i squared becomes a positive 3 times what's I squared? Negative 1. In the denominator, my i's are gone. Yay! 4 minus 9 times I squared is negative 1. So I'm just going to find my real pieces. This is negative 3. 10 minus 3. That's my real piece. Plus 17i divided by, this becomes 4 plus 9, which is just 13. And look, the I is in the numerator exactly as we wanted. So the trick is multiplying by a fancy form of 1. The fancy form of 1 was the conjugate. It's the exact same binomial except for the operation changes. If it's subtraction, it changes to addition. If it is addition, you change it to subtraction. Top and bottom. You can bring questions next time, but you should definitely try this. The assignment, shh, guys, listen carefully to the assignment, because it's 2 different places in your book. Connor? Okay, the first one is in volume 1. That is on your composition of functions. There's only 5 problems I'm assigning you. Page 282, 1 through 5, okay? Now, this imaginary and complex number stuff is in the volume 2 in the honors section, complex numbers. The honors section is the dark blue in the back of volume 2. And it's, the page number is actually an H. H35. 2 through 40 even. So most of you guys have that book at home. So look and see if you can find H35 at home. If you have an issue finding where the honors section is in your book, bring your book into me after school tomorrow and I can help you find where it is. It's just that dark blue strip in the back of volume 2, and they're all labeled H, so find page H32. Yep, just a minute.